Hello everyone, it's Angela, and today we're going to continue talking about forces. Now before we talked about intermolecular forces, but today we're going to be focusing in on forces that physicists use, and we're going to be doing that with 3 scenarios. Now say that you have a block of said mass falling through the air. Now, if we say that there is no air resistance, there's only one force acting on this block, and that is the force of gravity, or the gravitational force. This is the force that is pulling the block down, and is also the force that keeps us on the ground on Earth and not flying through the air. Now, let's say we had our falling block, and it falls on a patch of ice. Now, what are the forces? We have our gravitational force, but we also have a new force, and this is called the normal force. The normal force is the force that the ice is applying on the block so that it does not fall through the ice. Finally, we have our block with mass on ice. But now, let's say that I decide I want to push this block with my 2 hands. What are the forces? We got our gravitational force, we have our normal force, and then we also have the force of me pushing the block, and that is the applied force. Now, in each of these 3 scenarios, the block is what physicists consider a free body, and free bodies obey Newton's second law. Newton's second law states that the sum of all forces on a free body is equal to the free body's mass times the acceleration. And there are arrows above force and acceleration because they both have direction. Now, in terms of units, mass is in units of kilograms, acceleration is in units of meter per second squared, so the units of force are kilogram meter per second squared. Now, let's go back to our drawings to account for acceleration. In our first scenario, our block is falling down, so its acceleration is pointed down. Now, let's write out our equation. The sum of the forces is equal to the gravitational force, which equals mass times acceleration. So, you can see that because the gravitational force is the only force, it makes sense that the acceleration and the gravitational force are in the same direction. Now to our second scenario. We have a block on ice and it's not moving. So acceleration is 0. Let's write out our equation. The sum of the forces equals the normal force minus the gravitational force. And this equals 0 because acceleration is 0. Now we subtracted gravity because it is working in the opposite direction as the normal force. And from this, we can see that the normal force and the gravitational force are equal in magnitude but opposite in direction. Now for our third scenario. As we said, the normal force and the gravitational force are equal and opposite in direction, so I will not include them in our sum. So the sum of the forces is equal to just the applied force. And this equals mass times acceleration. So this is similar to the first scenario. There's only one force, and so what direction is the acceleration? In the same direction as the applied force. So that's our video today. Thank you so much for watching, and I hope you found this helpful.